Even if you take all the steps to avoid errors that we have discussed, you are going to make errors, and some of these are going to be difficult to find. That's where debugging comes in. So let's talk about debugging. First, what is it? It is the process of finding and resolving problems in your script. Why the term debugging? This term has been in popular use among programmers since 1940. The very first computers that were created used vacuum tubes. Now, you may not know what a vacuum tube looks like, but it looks like an incandescent light bulb. It has a glass enclosure. It has a vacuum inside, thus the name. And it has devices that control the flow of electric current. But these vacuum tubes in the old days could get quite warm. And they also emitted light. What does the emission of light do? Well, one thing it does is it attracts bugs, particularly moths. And so there were actual mechanical switches in the computer. So a switch would close on a moth, and the moth would quite literally disrupt the connection the switch was supposed to make. And because that switch was indicating something in the computer program, the program now would not work. So the process of debugging was literally going and removing the moths from the switches and cleaning the switches. Ever since then, we've talked about debugging whenever we're trying to fix computer code. Our studio offers quite advanced debugging tools. With that sophistication comes some complexity, and so we're going to hold off on looking at these and look at the more common way to start debugging, and that is to work through a set of procedures that I'll outline for you. But before we do that, the first step in debugging is to celebrate what you're about to learn. I know you may smile or laugh at me saying that, but I am going to tell you from personal experience, quite literally with a straight face and with 100% sincerity, that the most that I have ever learned in any programming language that I have learned, and I have learned a number of them, has been when I've been debugging. The process of going through and trying to figure out the errors in my code forced me to learn about every single aspect of that code, what an object does, how it works completely, how functions work, all the arguments, what they're supposed to do. I have no choice but to learn them and to learn them deeply. So this truly fits in the category of productive struggle. Yes, you should try to avoid errors. But when you have an error to fix and you're taking an hour to try to figure it out, if you do this in the correct fashion, you will learn in the process. It is possible to let frustration take over rather than the learning. But keep in mind, you're going to figure this out one way or the other, and then in the process of figuring it out, you're going to learn much. So start by celebrating that you have a chance to learn and to learn deeply. When we search for errors, we must be systematic. Read the error messages, obviously, and look for clues. Make sure that all the functions are present, that our libraries are loaded at the beginning. Test all user-defined functions before using them. Just as we expect a function in base R to work, we should expect our own functions to work. So make sure, before you save your function as a function that you can use later on, that it's working well, because later on, you're going to have to refigure out what you did if you have to fix something in your function. Use the common mistakes list that I gave you to help search for mistakes. Yet, even with all this, there's going to be times that you still cannot figure out what's going on, and you're going to have to do some more serious debugging. And when that happens, it's time to use the rubber duck debugging method. Again, your inclination may be to smirk a little and say, "What do you mean by the rubber duck debugging method?" This is not something that I am doing as a joke. Here's the Wikipedia entry for rubber duck debugging. And what I would invite you to do, what I would encourage you, please do this, do a web search on rubber duck debugging. You are going to have pages and pages of results. You are going to have testimonies from people who work with computer languages as a profession that this works. You're even going to find dozens of YouTube videos, and you should watch some of those, in which people explain how rubber duck debugging is a method that helps them to fix the errors in their code. So let's go through the steps of rubber duck debugging. First, set the rubber duck so that it can see your screen. It's not going to be able to help you unless it can see the screen. Prove to the duck that each function works. Now, how are you going to do that? You're going to have to show exactly what you're giving to the function. You're going to have to tell what kind of data is supposed to be returned, show the object that you're storing that in, and if you're not storing it into an object, you should temporarily store it into an object so you can make sure that you're getting the type of data back you're expecting to get back. If a function does not work, put the code in the global environment to fix the problems. If you have written a function and you've sourced it in, you need to actually look at the code of the function and make sure it's not the function that's causing the problem. You have to be able to trust functions. For each function or main body of the script, start at the beginning and explain in detail what each line will do. You have to start at the beginning. You have to not focus on where your error is occurring. You have to go back to the beginning. One of the common ways errors can occur in R is the error that you're seeing on, say, line 52 is actually the consequence of something you did on line 28. You need to go back to the beginning, and you need to take it in small little pieces. But what you need to show that duck is that you have to demonstrate each line does what you expect. You can do that by watching together as the objects change in your environment pane, or you could insert a print command, a temporary way of printing out the object so you can see it in your console. The key here is that you can't just say it works. You have to show the duck. You have to prove to the duck that it works. I often will put in print commands where I normally am not going to want them. I'll often create temporary objects in which I store something that I don't normally need to store, but I do it so I can look what's inside. What's helpful about the duck is that the duck needs to be convinced about every single line before you go on to the next line. It's really easy for us to look at something and say, I've already looked at that. I know it works. That's a function that I'm sure it's working. But that's not the same as convincing the duck. The duck hasn't seen that before. You need to show that it works. When a line's not doing what you told the duck it would do, fix it until it does. Now that may have fixed your bug, but it may not have. You're going to have to still run the script and see if it works. Work through the entire script, breaking it into sections if it's a long script. We cannot debug a 500-line script by looking at it in its entirety. We need to take it bit by bit. Break it down into as small of unit as you possibly can that will give you a result that you know what it should be and make sure it's giving you that result. And when you are done, thank the duck. The duck is your partner. The duck is your friend. And the duck is going to help you through some of the most difficult problems. Although I cannot require you to get a duck to help with your debugging, I strongly, strongly encourage you to do so and to start using this method. It has been very helpful to my students in the past, and it can be helpful to you.